Hi, I'm a master's student majoring in computer science, and this is how to do long division. Now, it is not as complicated as it seems it is, but it can get a little tricky if you don't pay attention or if you mistake some values for the other. So, just like regular division. Alright, so let's say you have a number, let's say 36 divided by 4. This is how we represent numbers in fractions or something divided by the other. So this is pretty simple. What you have to do is take the bigger number, write it down, and do another C and a dash on top and put the smaller number and write it over here. So we have 4 divided by 36. Now, what you're going to do is you're going to check the first number, which is 3, with 4. Now, if this number is bigger than 4, then you directly only divide this number with 4. But since 3 is smaller than 4, we're going to check for two numbers. Again, we'll check if 36 is bigger than 4. If it is bigger than 4, which is true for us, we directly divided it by 4. If it is not, we check it with another number, with another number, with another number. This arises when you have, say, 40, 400, 4,000, or whatever being divided with a number, or just in case when your denominator, which is this number on the bottom, is bigger than your numerator, which is the number on the top. So since we have to take two numbers together, I'm just going to quickly erase this because it's a little clumsy. So we have 4 divided by 36, right? So what you're going to do now is you're just going to multiply and see for a number which is smaller than a number that appears in 4's table or is a multiple of 4, and does not cross it. So you're going to say 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 fours are 16, 4 fives are 20, 4 sixes are 24. We still haven't crossed it. What were we on? 4 5 6, 4 sevens are 28, 4 eights are 32, 4 nines are 36. Okay, so we're at 9. So if we were dealing with any number between 32 and 36, we would take the number which is less. All the time, we have to take the number which is lesser than the number that we're dividing it with or barely equal to. But since 36 is a multiple of 4 and it goes into 4 9 times, we directly take 9, write it on top, have my system crash, put 36, subtract it, and take the remainder. This is the remainder. Since 36 goes perfectly with 4, we have a remainder of 0. Now, for instance, let's say instead of dividing 36 with 4, we were dividing 35 with 4. Now we know that 36 goes 9 times with 4, but 36 is greater than 35. So we need to take a number which is smaller than 36. So we take 8. We take 4 eights are, which is 32. We take 32, subtract it, and we have 3 as the remainder. Now we don't have 0. According to your problem, this should be good enough. But if they want you to go up till, say, 1 decimal place or 2 decimal place, what do you do after that? Well, it's simple. Since we no longer have any digits here, we're going to put a 0 and we're going to put a decimal point right after 8. The reason we're doing that is we need to get the decimal values after that, and this is how you do it without a calculator. So you simply just take the 0 down, and now instead of 3, you have 30. Now again, if you recount the table, we know that 32 goes 8 times in 4, and we need a number which is lesser than 30, so we can't take 32. So we check for 7. 4 sevens are 28. And is 28 less than 30? Yes. So we can take 7 and we take 28. We subtract it and now we have 2. Now you could stop here if you're just looking for one decimal place, but if you're looking for more decimal numbers, you again put a 0. You don't put another decimal pointer. One decimal pointer that you put previously is good enough. You bring the 0 down. Now instead of having 2, you have 20. And you keep on doing this, well, until you get zeros, or as in your remainder is 0, or your question specifies how many decimal integers they're looking for. Decimal numbers they're looking for. I'm sorry. So again, we know 7 fours are 28. We can't take that. We check for 6, which is 24. Again, 24 is greater than 20. We can't take that. Now we check for 5. So you go on one number. When you know a certain number, you just go decreasing it until you reach the number. Or if you're really good with multiplication and you can check it in your head, I suggest just go on multiplying then. So we're checking for 5. 4 fives are 20. That's perfect. So now you put a 5 here and you put a 20 and you have your remainder 0. Now you could still keep on going, putting 0, and then it would just be a 0, 0, 0, which doesn't make sense. Any number of zeros after a decimal number is still a 0. So you can just stop here and you can just say that answer is 88.75.